Now, let's take a look at another equation, and we notice that not only are none of the coefficients opposites, none of them are the same. Remember that our goal is to get the coefficients of one of the variables to be opposites. Now, if we look at these two coefficients, for instance, we note that if we multiply the second equation by -4, that the coefficient of x will be -8. Then we'll have coefficients that are opposites and we'll be able to solve. So let's go ahead and do that. The first equation will remain the same. 8x plus 10y equals -26. The second equation we're going to multiply by -4. -4 times 2x is -8x. 6y times -4 is -24y. And -24 times -4 is +96. Now we can add the equations. 8x plus -8x is 0. 10y plus -24y is -14y. And -26 plus 96 is 70. If we divide both sides of the equation by -14, we'll get y equals 70 over -14, or y equals -5. Now we can find x by substituting -5 for y in one of the equations, and we'll do that with the first equation. So we're going to use, I'll come over here and do that. We'll use 8x plus 10y equals -26. So we'll let y equal -5, so we have 8x plus 10 times -5 equals -26. This would be 8x minus 50 equals -26. That's 10 times -5 is 50, so that's -50. We're going to add 50 to each side, and we'll get 8x equals 24. And then divide both sides by 8, and x equals 3. So our solution then is x equals 3, y equals -5. And let's check that using the second equation. 2x plus 6y equals -24. So we'll take 2 times x, which is 3, plus 6 times y, so that's 6 times y, which is -5. That equals 6 plus -30. That's -24, and our solution is correct. Now in this example, we see that not only are the coefficients not opposites, none of the coefficients are the same, and unless we use fractions, none of the coefficients can be, in one equation, can be multiplied by an integer to get a coefficient in the other equation to be the opposite. So if we look at these two coefficients here, 3y, -3y, and -4y, we can kind of multiply one by the other and adjust our signs so that they become opposites. If we multiply -3 by -4, the coefficient of y will equal 12. And if we multiply -4 by +3, this coefficient of y, the second one, will be equal to -12, and that's exactly what we want. So let's show how the multiplications work. First equation multiplied by -4, -2x times -4 is 8x. -3y times -4 is 12y, positive. And 6 times -4 is -24. In the second equation, we'll multiply by 3. 9x times 3 is 27x. -4y times 3 is -12y. And -27 times 3 is -81. Now we can add the equations. 27x plus 8x is 35x. 12y minus 12y is 0, and negative 24 minus 81 is negative 105. We divide each side of this by 35, and we get x equals negative 105 over 35, and that equals negative 3. Now we'll use negative 3 for x, and we'll use the first equation to find out what y is. So we'll use the equation negative 2y minus 3y equals 6, and we'll let x equal negative 3. Sorry, that would be negative 2x. Let's get that correct. So we'll let x equal negative 3. So this is negative 2 times negative 3 minus 3y equals 6. Negative 2 times negative 3 is 6 minus 3y equals 6. Subtract 6 from each side, and we get negative 3 equals 0, or y equals 0. So now our solution is negative 3, 0. And we can check our solution in the second equation. So we'll use 9x minus 4y equals negative 27. 9 times x, which is negative 3, minus 4 times y, which is 0, equals negative 27 minus 0. That equals negative 27, and that is as it should be. So to summarize, here are the 4 systems that we've solved. Starting at the bottom, we were able to add those 2 equations together to eliminate a variable directly because 7y and negative 7y are opposites. In the second system, we had to multiply one equation by negative 1 and then add the equations together to eliminate y. In the third system, we multiplied the second equation by negative 4 so that the coefficients of x would be 8 and negative 8. And then we added to eliminate x. And then finally, in the top system, we needed to multiply the top equation by negative 4 and the bottom equation by 3 in order to get the coefficients of y to be opposites. Then, whichever variable we chose to eliminate, let's say we chose to eliminate x, we added the equations to eliminate the variable. We then solved for y. We used one equation and the value we got for y to find x, to solve for x, and then we checked our xy solution in the other equation. And then, just for completeness, if we eliminated y first, then we would use the equation that resulted to solve for x. With one equation, we would use that value of x to find y, and then we would, again, check the xy solution in the other equation just to make sure that it works.